Hello everyone, my name is Muntasir. Today I'm going to show you how to make a stopwatch using a microcontroller. Here ATmega16 is used. So let's take a look at the circuit. So here's the circuit. I used 1602 LCD screen. It has 16 columns and 2 rows. So each row can display 16 characters. So in the microcontroller, port C pin 4, 5, 6 and 7 goes to the data pins of the LCD, and port D pin 4, 5, 6 goes to the control pins RS, RW and E. So here is two buttons are used and they are pulled up. That means if they are not pressed, a high signal will go to pin 2 of port D and pin 3 of port D. So this button is start and stop, and this is the reset as in the reset for the stopwatch, not the actual reset of the microcontroller. So let's talk about some calculation. In this project, the internal oscillator of 8 megahertz is used. So 8 megahertz and 256, I used 256 as the prescaler. So if we divide 8 million by 256, we get 31,250. So at this point, let's take a look at the design of my project. So here, these are the millisecond, these are seconds, minutes and hours. Okay, so the least unit is milliseconds. So actually what I'm doing is we will count the millisecond, and based on the milliseconds I will increase seconds, minutes and hours. Okay, so per seconds my timer will count 31,250. so that means per millisecond it will count, if we divide it by 1000, that's the result. It's 31.25. So let's take a look at the timer compare register, output compare register and TCNT0 register. So how they work is, as I'm using the timer 0 in CTC mode, so the OCR 0 register, at first a value will be assigned in OCR 0 register, and TCNT 0 register will continuously compare the value of TCNT with OCR 0. Okay, TCNT 0 with OCR 0 register. So TCNT 0 will start counting from 0, then it will count 1, 2, 3, and when it gets to 30, it will go back to 0. Okay, so if we put 30 on OCR 0 register, that means we get 31 cycles. So that's why I will use 30. I'll assign OCR 0. I will assign 30 to OCR 0 register. Okay, so that was the pretty much hardware part, and let's jump into code. So here I opened a project in Atmel Studio, and I included the lcd library.c and lcd library.h files. So if you Google it, you will find them. So they're pretty available. So I'm not going to show you how these LCD functions work. So that's other topic. So let's start coding. Here I defined FCPU 8 megahertz, and I included some header files. So basically I will use three functions: button conditions, display, and convert. So I will implement them a little later. So here I initialized here I declared some variables. So they are millisec, sec, min, hour, start, stop flag. Okay. So here's the initialization section. So at first I'm going to declare port D pin 2 and pin 3 as input pins. So next I'm going to actually it will be DDR-D. So the TCCR 0, let's take a look at the TCCR 0 register. So here's the TCCR 0 register. These three pins determines the prescaler. So you can see if the value of CS02 is equal to 1 and the other two are 0, the prescaler is 256, and the WGM01 determines 01 and 02 determines the mode of the timer. So I'm willing to use CTC mode. So let's put 1 into WGM0. bit. So 1 left shift WGM01 and 1 left shift CS02 for the prescaler 256. So then the OCR0 is going to be 30, and for formality TCNT0 should be 0. Okay. Next thing is another thing is TIMSK. As I'm using interrupt, output compare interrupt, I think TIMSK. So this pin should be high as I'm going to use interrupts. So it's the interrupt enable pin for output compare mode. So OCI is 0, is high, and I have to, this function enables the global interrupt, and for LCD I have to initialize the LCD. It's a good practice to give some delay after initializing the LCD. Okay, so next thing is here's the initialization section. Next thing is so let's put some displays. So first parameter is the column number, and next one is row, and there is the string MNSC and millisc. Okay, and then let's, okay, everything seems fine. So here are the three functions. Let's talk about them. First, the convert function will convert the integer value to the character values so that we can display them in the LCD screen. Then the display function will display the strings to the LCD, and button conditions are for the start, stop, and reset button. And here is the interrupt service routine. So timer 0 compare vector. So after every 31 cycles of the timer, these vectors, this interrupt will be enabled. So in here we will check if there will be if condition. I'll talk about it later. So milliseconds will be plus, and then if milliseconds is greater than or equal to 1000, supposed to be 0, and second plus. If second is greater than or equal to 60, then second should be 0, and minute plus. Okay, if minute is greater than or equal to 60, then minute should be 0, hour plus plus. Okay, so that is pretty much the timer compare vector. So let's go to the convert function. So we declared the string, 4 strings, strmilsec, the two will be milliseconds mod 10 plus 0. So the value of milliseconds mod 10 in the character version will be assigned to millisecond string at second index. Actually, it's third index. So if the value of millisecond is, let's say the value of millisecond is 435, so the value assigned there will be 5. And then str millisecond 1 should be milsec divided by 10, and that should be mod 10. 0. So for 435 divided by 10 is 43, and 43 mod 10 is 3. So we get 3 there, and str in second 0, the 0th index will be millisecond divided by 100. Okay, of course, plus 0. Here the plus 0 is used. Plus 0 in character version is used. In this character version, I use the character version 0. It means it will replace by the ASCII value of 0. So ASCII value of 0 will be added with this result. Sorry, with this result. So what we will get here is the ASCII value of the actual number what we are looking for. Okay, so let's do this for second, minute, and hour. So str sec 1 is equals to sec mod 10, plus 0, and str sec 0 divided by 10. Okay, I hope you understand this. So let's do some copy paste. Oh, sorry, I did the wrong one. Okay, doesn't matter. And hour, hour, and hour. Okay, so it's pretty much the convert function. So let's jump into the display function. So I'm going to use some delay, about 100 microseconds. LCD right string XY. So the column number should be 13 for millisecond display. So str millisecond 13. Okay. Again, there's some delay of 1 micro. Let's copy second, minute, and hour. Okay, so second should be started from 10, and str second, str minute, then it should be started from 7, and hour should start from 4, right? So it will be hour. So that's pretty much the display function. So let's go to the button condition function. Now here I declared a start stop flag. This flag will determine whether our stopwatch is on or is running or not. Okay, so let's give a condition. If the start or stop button is pressed, so pin D and 1 left shift PD PD2 is equals to 0. So if is, it means is start stop pressed. So if the button is pressed, then we will check the flag variable. If start stop flag, if the flag is 1, that means the timer is running, stopwatch is running. So what we have to do is start stop flag should be 0, that means turned off, and the timer should be turned off. Okay, so timer should be turned off. So if we do this, if we make the CS02 bit of TCCR0 register 0, then the timer will be off. Okay, else that means the start stop flag is 0, then start stop flag should be 1, and TCCR0 register 1 left shift CS02. Okay, so this is for the start or stop condition. If start or start button is pressed, this condition will apply. Oh, another important thing about the button is we have to use the loop. It is because if we press a button, the if we press a button for some moment like this, so the loop will run itself. Okay, the code will not go in another place. Okay, you know what I mean. So, and if pin D of PD3 is pressed equals to 0. Let's give some brackets. Now for the reset pin, the condition should be everything will be 0. Okay, first of all, the start stop flag will be 0. That means the timer will be in stop mode. Then the timer, actual timer, DCCR0 should be off. 1 to CS02. Okay. Then millisecond variable should be 0. Second should be 0. Second should be 0. Minute should be 0. Hour 0. And the TC entry register is 0. Okay. So now here's the thing, we have to call display function now. Here we are calling display function because after giving these values you have to display it for the last time, because in the actual loop in the main function I'm going to give this condition for display. If start stop flag is 1, then we'll display in the main function. So when we give the start stop flag a 0, then that's why display should be called here once. Okay, so here in the reset pin this loop is not necessary, because if you reset it, then it will automatically drive everything to 0. Okay, so let's call the functions in the loop. First you can call the button condition function, then convert function, and then the display function. So that's pretty much it. Oh, so you have to give the condition start stop flag. So if the timer is running, then display. Okay, and here in the interrupt pin I said I will give a condition. The condition is if the flag is running, then increase millisecond. Okay, if the stopwatch is running, then increase the millisecond variable. Okay, so I guess that's pretty much it. Let's build the code. Oh, no errors. That's cool. So let's run it in Proteus. So it's working fine. You can see if we pause it. So this is the start stop button. So if we pause it, it pauses, and if we reset it, so you can see it goes back to 0. So that's almost it. If you like this project, please give a like, and if you have anything to ask, you can comment. So that's it. Peace be upon you.